Hi, my name is Shannon from Strategic Intervention Solutions. Thanks so much for joining us. Today we're going to talk to you about how to do the Math Might Showdown subtraction strategies. In our previous video, we've shown you how to use all of the characters from our subtraction bunch from the Math Might, such as Springling, Minni and Subbi. We've also done some problems with DC, as well as our T-Pops, which does the traditional. We want you to check out those videos before going up to decimal. So the idea here in this video is that students can also use these same strategies they learned in first grade with subtraction all the way up through 5th grade using decimals. This video will be more done as a tutorial video showing the different examples, but you could use this with having a partner number talk, where you might have a game board and students might put, after they roll the die, they're going to put their counter on a strategy that they want to try out and kind of show how they would solve it. We also could do it with different kind of number talks in your classroom. It's going to feature our newest pencil toppers that we have. And so for our first strategy, we're going to show how to use Springling. Springling has fancy eyelashes and fluffy fur, and so she likes to hop on the number line. I'm going to select a problem that I think would lend itself well to Springling. And so I'm going to do 8 4/10 plus 3 5/10. You notice I didn't say 8.4 and 3.5 because we want students to attend to place value by saying the value of what we're looking at. Springling loves to hop on an open number line, and she likes to hop in friendly chunks. She really, even though T-Pops is one of her friends, she really likes really doing the traditional method and regrouping. So she likes to hop on friendly numbers on the number line. With decimals, if she's in a part of a total, she likes to get on a whole number, sometimes to make it easier. So if she's at 3 5/10, she might decide to go all the way up to a 4. Because as far as she went was only 5/10, I'm going to kind of make a little hill to sort of show how far she went. We like to make big peaks when we're talking about whole numbers. So if she's gone from 3 5/10 to 4, we know that she's gone 5/10. We're going to now have her go all the way up to the number 8, hop, Springling, hop, and she hops a whole 4 going across. And then she's going to go from her 8 to 8 4/10 by making a small hop using the 4/10. She likes to add together her hops. Doing the large peaks and then kind of these smaller hills helps students with fractions. It also helps students with, money, obviously the whole number versus the part. It also could help with elapsed time as well. So we know that she has hopped 4 9/10, which tells us the distance between 8 4/10 minus 3 5/10. I'm going to keep my counter on here. Students can agree or disagree with some of our math STEM questions that we have. Students can also decide if they think this was the most efficient way to solve this problem. Some students might argue that the traditional method or another way of solving this may have been easier, but the idea here is that they can kind of look at the jet plane way or kind of our pokey car way to get there to talk about which ways are most efficient. I'm going to roll the die, and this time I'm going to roll Minni and Subbi. And Minni and Subbi stand for minuend and subtrahend. Minuend, which is the first number in subtraction, and the subtrahend is the second number in subtraction. They like to shift the number line, kind of to prevent a regroup as they're looking at different numbers. So they kind of can shift it one way or another to prevent the way that regroup might be going. And so we're going to kind of look at where they might go so they can kind of shift that number line together. So I'm going to take a red counter and I'm going to put it on one of the problems that I think would be a good way to kind of shift the number line as we go. So I might start off with 8 2/10 minus 4 9/10. So I'm going to grab my Minni and Subbi pencil, which has Minni on one side and Subbi on the other with their tail kind of coiled. They like to shift the number line, and so I'm going to grab my Minni and Subbi pen to show how that would look. 8 2/10 minus 4 9/10. When we look at the distance that Minni and Subbi are going, they like to shift the number line. So the distance is between these two numbers that they're subtracting. If I look at this in the traditional way, it's actually causing a regroup. So students could actually shift and change the numbers to make it so there isn't a regroup as they're doing it. So if I'm looking at the 4 9/10, is it going to help me to go up to the 5 or is it not? Is it going to help me to go up to a whole number 9 and kind of regroup? Is it going to help me to go up, even further? Whatever one way shifts, the other one has to shift. So in this case, to maybe prevent a regroup, I might want to change my 4 9/10 and go up to 5. If I go up to 5, I've technically added on 1/10. If we look at string to kind of show the distance between the two numbers, I know the original distance was here. If I look at what's happening, the tail is kind of sagging. Minni and Subbi are sisters and they're twins with adjoining tails. They don't like it when their tail is dragged in the mud, so she's going to yell to her sister to also move up the same distance. So in this case, our Minni kind of moves, or Subbi moved, and now Minni's going to move up to 8 3/10. So she also moved up 1/10. What we're trying to look at is the distance of the original problem and the distance of our shifted problem is the same. If I were to kind of write this new problem down, it's 8 3/10 minus 5. That's a lot easier for kids to solve because they don't have to have a regroup on here. So she just moved one over to prevent the regroup happening here. Students usually like this strategy when they're going across zeros with whole numbers and decimals to make that shifting of the number line easier. We're going to continue showing this with now our blue counter is going to go next, and we're going to pick out a problem that would lend itself to using DC. DC likes to rename numbers or decompose them to make them easier. And so we're going to pull out our DC pencil. He has a hard hat and carries a mallet because he likes to smash or decompose numbers to make them easier to solve. I'm going to go ahead and put my blue counter on 5 4/10 minus 3 6/10. If DC were to smash these numbers and just decompose them, he would be doing great to take the 5 minus 3 because they're nice whole numbers, there's no regrouping. But when you take 4/10 and you try to take away 6/10, you end up with a negative number. So DC is actually going to rename this number. He's going to rename the 5 a 4 and bring those 10/10 over here to make 14/10. When we're doing the traditional method, it's the same concept. We don't want to say borrowing because we're not really renaming, but we're not really going to give it back, but we're actually renaming or regrouping. So in the T-Pops or traditional method, that's the same thing that's happening. We're making the 5 a 4, and we're taking that one whole and bringing it over to make it 14/10. You want to make sure you just don't write 14 down here because that can be confused that it's hundredths. So I'm writing the tenths. I'm going to decompose this and subtract decompose the 3 6/10 to 3 6/10. I'm going to subtract to get 1. And now when I go to subtract this, it's not using a regroup anymore. So I know that 14 minus 6 is going, or really 14/10 minus 6/10 is going to be 8/10. So I get 1 8/10 for my answer. Same thing if I were to subtract here. I know that I would have that same answer if I looked at it, in the traditional way, which is great. The last one we're going to show is, obviously, we don't need any help with this one, is T-Pops. We like for you to be able to use the place value discs and strips that are on our website on sisforteachers.org using the place value decimal tiles and our whole numbers. Students could go ahead to show that problem in the traditional way, just as we've talked about before. We could also have them show it showing a pictorial model of what's really happening. So if I were to actually build 9, I'm going to show my 9 wholes, so my 9, there's a whole number. And then I'm going to show my 3/10. I know this isn't going to work to solve it this way, so I'm going to have to rename it from 9 3/10 to 8 13/10. So that would look this way pictorially. In the previous video, I showed what this looked like concretely, so you could get the idea. So we kind of have our 7 here, and then we're going to add our 8, 9, 10. Now students can go ahead and subtract knowing that we've renamed this number from 9 3/10, we renamed it to 8 and 13 tenths, right? And so as kids kind of look at what that actually is, they're taking their 13 and they're taking away their 13 tenths and they're taking away 5. So they know they are left over with 8. When I have not just, this is 8 whole numbers minus the 1. So I take away the 1 and I end up with the 7. So I know that I get 7 and 8 tenths using it with T-Pops. The way this game is played is you could do it different ways. You could show it on level 1 where you're just playing, and as soon as the board is covered, it's just practicing our strategies that we're doing. The idea of the Math Might Showdown is to kind of show off your skills to somebody else. Students can also work on trying to get 4 in a row, horizontally, vertically, or diagonally, to see if they can stretch their math skills to solve them. Even if that strategy might not be the most efficient, they could talk about this, but the idea is that they can get that 4 in a row and be able to say, they kind of could win the game in that way. If this level is too high for you, you also can go ahead and use your customized sheet that's in the download that also comes with our car and our airplane as well, and you can look at the different videos on sisforteachers.org via our YouTube channel. Thanks so much for hanging out with us.